It's time for fun with math, and today we're going to do the first part of a two-part video, and we're going to talk about the law of sines. And so what is the law of sines? Well, here's the formula, and what's interesting about this formula is that it doesn't just work for any triangle, it doesn't work just for right triangles, it works for any triangle. So if you have a triangle with angle A, B, and C, and then sides little a, little b, and little c, then this formula will hold. If you take the sine of the angle and divide by its opposite side, and then the sine of another angle divided by its opposite side, these will be exactly the same. And the same will work for the sine of c divided by its side. We'll talk about the law of cosines in the next video. But first, let's try to understand why this formula actually works the way that it does. So here's the law of sines, and we want to try to explain, right? We want to use the triangle to explain the law of sines. Now notice this is any triangle. It doesn't have to be a right triangle. So to sort of prove why these equalities actually hold, the idea is you take a look at this triangle. Now remember what we've been doing, we've only been working with right triangles. And so if we're going to show something for a triangle in general, the idea on this one is not to think outside of the triangle, but think inside of the triangle. So we'll take this triangle and we can do a very simple construction. We can simply drop down a perpendicular from this point down to AC down here. So it's a perpendicular. And what do you notice now? Instead of one general triangle, hopefully you can see you actually get two right triangles. And we'll call this distance here little d. And so what we can do now is I can use this angle A, and I can write down a formula for d. So let's see here. I can write this as sine of d is, or sine of A is equal to d divided by c. So the sine of angle A is equal to, it's the opposite over the hypotenuse, remember, SOHCAHTOA. And so I know that the sine of this angle A right here will be the opposite side over the hypotenuse, so this is equal to d over c. And so what this implies is that if we multiply both sides by c, we're going to get d to be equal to the sine of A, right, times c. So we'll move c over. So just multiply both sides by c, and we get d equal to c times sine of A. Now notice that was just this triangle right here on the left. But there's another right triangle. So here's the one we just used. But there's another right triangle on the right. And so what we're going to do is we're going to use that right triangle now. And we can use that to create an expression that involves this d. So now this one, you have angle C here, so we'll use the sine of angle C is equal to the opposite over the hypotenuse, so it's equal to d over A. And so this implies, if you multiply both sides by A, that d is going to equal A times sine of C. And so now what do we have here? What we have is d is equal to this, and d is equal to that. So that tells me that this needs to be the same thing as that. So I can set those two things equal to each other because they're the same. So I have c times sine of angle A equal to A times sine of angle C. And then what I can do is I can divide out both sides by A and C. So we can divide everything out here. This side by AC, this side by AC. What you'll notice here is that the C's are going to cancel on the left, the A's are going to cancel on the right, and we wind up getting this equal to that. So we have the sine of A divided by little a equal to the sine of C equal to little c. Now you may be wondering what happened to this expression right here. Well, we can show that this is equal to either of these two things by, instead of dropping a perpendicular down from angle B here, we drop a perpendicular down from angle A. And if you do that and repeat the same sort of arguments we did here, basically do the same algebra, what you're going to find is that the sine of angle C divided by little c is equal to, now you have this angle over here, the sine of angle B divided by little b. So you just repeat this process up here, and then the outcome is this expression. And then if you piece these two expressions together, this is equal to that, that is equal to this, then these two things have to be exactly the same. And so we get this string of equalities here, this equals that, and so they're all equal to each other. So that's where the law of sines actually comes from. Now, you don't have to memorize this process, but what I do want you to take away from it is how do you work with a triangle in general? Any old triangle. Well, the way that you can often work with it is you can split it up into right triangles. And so this is sort of a problem-solving, well, this is a problem-solving technique. The idea is if you know how to solve certain types of problems and you have a new type of problem to work with, to solve that, sometimes you can, pull it back to those old problems that you can already solve. All right, let's do an actual problem though with the law of sine. So we want to solve the triangle. So when it says solve the triangle, the idea is you want to find basically this missing angle, because that angle is missing, and you also want to find this side little b and this side little c. So we're looking for basically angle C here, this side C, and this side B. And we're going to use the law of sines to do this. And so let's see, it's easy to find this angle. So remember, the idea to find angle C, right? So find angle C. All you have to remember is that these angles are going to add up to 180 degrees. So if you take big C plus 38 degrees plus 102 degrees, you should get back 180 degrees. And so on the left you have, so it's sort of like your equation here, and there's my picture, what I'm trying to find. And so now I can just basically add these two numbers together and get 140 degrees equal to 180 degrees. And now I can solve this equation that I found. So I can solve it, and when I solve it, I subtract 140 from both sides, and I get C equal to 40 degrees. So I know immediately that that's 40 degrees. All right, so now what do I want to do? I want to find little b and little c, right? So I'm going to find little b and little c, the lengths of these two sides. So let's try to find little b first. So I can, to find little b, I'm going to use my sort of part of my law of sine. So I know that the sine of the angle b divided by little b is supposed to be equal to, and they give me this side here, 20. And I know this angle is 38. So I'm going to use that the sine of a divided by little a. And so now that I know my equation, I can basically plug in here. So I'll plug in sine of angle b, so sine of 102, divided by little b is what I'm looking for. And so this is going to be equal to, and on the right, I have the sine of angle A, so the sine of 38, and then divided by 20. So I'm going to take this equation, I'm going to solve for b. It's basically a rational equation. What I can do is I can just simply flip both sides. So I'll flip this side and this side. And then what do I get? I just get b divided by sine of 102 on the left is equal to 20 divided by sine of 38 on the right. And then I'm going to clear the denominator on the left because I'm trying to solve for b. So what I'm going to do is I'm going to multiply both sides here by sine of 102. So I'm going to multiply it here, and I'll multiply it there. When you multiply on the left, it's going to cancel, and I get my answer for b. So b is going to equal 20, and then times the sine of 102 degrees, and divided by the sine of 38 degrees. So that's the exact answer, and if you like, we can approximate this. So if you have your calculator, you take out your calculator, and make sure your calculator is in degrees. So let's put our calculator into degrees here. So hit mode, we'll put ourselves in degrees, so change this to degrees, and now I can crunch b. It's going to be 20 sine of 102 in parentheses, then divide by sine of 38 in parentheses. And so to one decimal place, it's about 31.8. So let's write this down here, 31.8. So approximately 31.8. So that's my side B here. If you want, I can write this down here, approximately 31.8. And now I need to find my other side C. Now when I find side C, I won't use this approximation because it'll make me off a little bit more. So what I'm going to do is I'm going to go back right here and find another equation to find my C. And I'm going to use, let's see, I'm trying to find C. So here I'll put sine of angle C divided by little c will be equal to, I try to use the information they give me. So they give me this angle and they give me this side. So we'll use the sine of A divided by little a. So there's the formula. That's the piece of law of sines we're going to use. And it's really, again, just a plug and chug. So let's just plug in. So the angle C is 40 degrees. So you have the sine of 40 divided by little c is what we're looking for. And on the right-hand side, we have the sine of angle A, and angle A is 38. So 38 degrees. And then divided by the side A, which is 20. And we basically go through the same steps. I'm going to flip the left and flip the right. So what I have on top now is C, and then on bottom I have sine of 40. And that's the same thing as what? 20 divided by sine of 38. And then I'll just multiply both sides here by the sine of 40. So we'll multiply everything here by the sine of 40. So when you multiply this side by sine of 40, the sine of 40's cancel and you get C equal to. And when you multiply this side by the sine of 40, you get 20 sine of 40. And then divided by the sine of 38. Which is approximately, so that's the exact answer, but it's approximately, using my calculator, we can type this in. So this is going to be 20, the sine of 40, in parentheses, divide by the sine of 38, in parentheses. And out pops my answer of 20.88. And if you like, I can round this just to one decimal place. Let's say 20.9. So it's about 20.9. So this C right here is about, so approximately 20.9. And so that's how you use the law of sines to sort of solve the sides of this triangle. Okay, let's move on to the next example. So the next example is a word problem. And so let's see how we can use the law of sines to solve this word problem. So in this one, it's a little bit harder because you have to make the picture. In the last one, they kind of gave you the picture, and then you just use the law of sines to solve the problem. So in this one, let's see what we have. We have a tree that is perpendicular to the ground and sits on a straight line between two people located 420 feet apart. All right, so here's the idea. From that sentence, I have two people. Here's another person. And they're 420 feet apart. So 420 feet apart. And there is a tree that stands perpendicular on the ground. Now, it doesn't say where the tree is. It doesn't say it's in the middle or to the farther to the right, to the left. So let's just put the tree, for right now, let's just put the tree a little bit farther to the right here. But let's not put it in the middle, because if you put it in the middle, you're going to start making assumptions. So here's my tree right here. There's my tree. And what it says is that the angles of elevation from each person to the top of the tree measure 50 degrees and 66 degrees respectively. So what that means is if you measure the angle here, basically, up to the top of this tree, this angle right here says it's about 50 degrees on the left. And then over here, let's say, the angle on the right is about 66 degrees. And then what do you need to find? You need to find how tall to the nearest tenth of a foot is the tree. So what we're looking for is this height of the tree, which we'll call it h. So what we're trying to do is we're trying to find h. Okay, so there's my picture, and now I have to come up with an equation here for h. So this one's a little bit tricky, but you can kind of help yourself along if you make up what we call sort of an auxiliary variable. So over here I could give this side a name. Let's just call it a. And what I know is that if you take the sine of 50 degrees, it's going to be the opposite over the hypotenuse. And so here, if you want, you could say the sine of 50 degrees is going to be equal to that h over a. And so you can solve this for h by moving over the a, and this will tell you what? This will tell you that h is equal to a times sine of 50 degrees. And so now our problem is, instead of finding h, we need to go figure out what this a value is. All right, now I haven't used the law of sines yet, and I know I need to use it in this problem because it's a law of sines problem. So how do I find that a? We have to realize that there's actually another triangle. You know, these two triangles are pretty obvious, right? This right triangle right here, that's the perpendicular part, so that's our right angle. And then that triangle on the other side is kind of obvious too. What's may not be so very obvious to you is that there's actually a third triangle, which is a combination of the two. So if you kind of stand back a little bit, you'll realize that there is one more triangle here. There's this triangle on the very outside that combines these two. And that's the triangle we're going to use with the law of cosines, or law of sine, sorry. Law of sines. Right, and we're going to use that because we know this distance on the bottom is 420 feet. And so what we can do is we can use the law of sines because we actually know this angle too, right? So this angle right here, that's 50 and that's 66. So if you add 50 and 66, you get 116. And then we want to find out the angle, so we just take 180 and we take away 116 from it because we know all the angles add up to 180. We find out that's a 64 degree angle right there. So what I can do is I can write that angle is 64 degrees, and then I can use it, so 64 degrees, then I can use it over here. I can take the sine of 64 degrees and then divide it by, what do we write that? Sine of 64, you don't need to write the degree marker. Then divide it by 420, because it's its opposite side, and that'll be equal to, now I'm looking for a, remember, so I'm going to use this angle, and then of course a, so that'll be equal to the sine of 66 degrees divided by little a. And so we can solve this now for little a, so we basically just flip both sides here, so you're going to get 420 divided by sine of 64 is equal to a divided by sine of 66. We'll multiply both sides now by sine of 66 to move it over, so multiply both sides by sine of 66. So multiply this side and multiply that side. When you multiply the right hand side, you just get back a, so you get a here. And then when you multiply this side by sine of 66, you're going to get 420 times sine of 66 divided by that sine of 64. And so now that we know a, we can take our a and plug it back over here in for a. And so h will equal now 420 sine of 66 degrees divided by sine of 64 degrees, and then all times the sine of 50 degrees. And so now that we have our formula, we can just basically just solve by plugging into our calculator. And so this is the, hold on one sec, this is the exact answer. So here's my exact answer right here. And then it does say, though, approximate to the nearest tenth of a foot. So let's just plug it in. So I have 420 sine of 66, and then divided by the sine of 64 in parentheses, then all times the sine of 50 in parentheses, Hit enter, and it spits out our answer of about 327 feet, but to the nearest tenth of the foot would be, oh yeah, just 327.0 feet, because that's a 1 there. So this would be about 327 feet. All right, so what did we do here in this video? We talked a little bit about the law of sines. So what is the law of sines? It's just a sort of a relationship, a formula that works for any triangle, not just right triangles, but any triangle, and this is the formula. Of course, it's called the law of sines because you're using the signs here in each of these expressions. In the next video, we'll talk about what is the law of cosines, and you can see here the law of cosines uses a cosine. That's why it's called the law of cosines.